So we're almost done, and we're going to put everything together. So we want to rationalize the denominator, make sure there's no square roots on the bottom, and we also want to simplify. So with this, you could say, okay, well, I need to rationalize it, and you know that you don't need the 2, but I can just do 18, top and bottom, square root of 18. And that will get you the right answer, but you, well, assuming you did it correctly, but 18 times 18, I have no idea what that is, and 24 times 18, I don't even know what that is. But what I do notice right away, 5 and 2, that can't be simplified, that's the fraction that it is, but 24 and 18 can. So I'm going to put this, there's a -5 and there's a 2, and then we're going to make this one giant fraction of 24 over 18. And that can be reduced. These can both be divided by 6, maybe? So I have -5 over 2 and the square root of 4 over 3. And now, scroll down here, -5 over 2, and I've got the square root of 4 over the square root of 3. And I can make that one big fraction. So I've reduced it. I've got, you can look at the top here, the -5 over 2, I still have that. With the 24 over 18, I used the rule that allowed me to join it, to simplify, and then unjoin it, to separate it. And that allowed me to make these numbers a lot smaller. So now when I rationalize, I'll multiply it by the square root of 3. Multiply it by the square root of 3. And that is a lot easier to do than the square root of 18. So on the top, I've got a -5. And I got a 4 times a 3. The -5 is the outside number. There's none on this one. But there is an inside number of a 4 and a 3, and that's a 12. And on the bottom, the outside number is a 2, and the inside number is a 9. I can keep going here. The square root of 9 is just 3. Now 12, square root of 12. So I'm going to do this off to the side here. -5 square root 12. 12 can be simplified to 4 times 3, and 4 can be simplified to 2 times 2 times 3. And I can take a group out. This is the first time we've seen that we can actually simplify one of these things. So the 2 can come out. So there's a -5, there's the 2 that came out, and the leftover is just a 3. So -5 times 2 would be the -10, square root 3. So when I have this -5 and 12, you should notice that the 12 is 4 and 3, and the 4 is a pair, a 2 and a 2. So that requires some simplification. So instead, I'm going to rewrite that. -5 and root 12. We did all the work here, ends up becoming -10 square root 3. And so I got -10 square root 3 all over 6. And then the outside numbers can both be divided by 2. It looks to me like I've got -5 square root 3, 6 divided by 2 is 3. So there is a lot of work there. So again, we probably could have just multiplied by the square root of 18. But that gets you a really huge number. So we join the two radicals together to make a simpler fraction, which we then split back up. And now when we rationalize, that's like 1, 2, 3 different steps we did there. Join them together, we simplified, we split back up. But that allowed us to rationalize this, again, without a calculator, which is really helpful, because the number is quite small, we were able to do it. 3 and the 3 becomes a 9, the 4 and the 3 becomes a 12. Unfortunately, that -5 root 12 could actually be simplified by taking out the 2 to become a, not -5, but now taking out the 2 became a -10. And the inside stayed a 3. So I wrote that down here. And square root of 9 also could be simplified to a 3. So in the bottom we have a 6, on the top we have a -10 root 3, and the outside numbers can both be divided by 2. The same thing would apply here. I could multiply by the square root of 21, but I have no idea what that is. So instead, I'm going to join these fractions together and then simplify it and split it apart. So 10 over 3, and join these fractions together, 27 over 21. Now 27 and 21, those can both be divided by 3. 27 divided by 3 is 9. 21 divided by 3 is 7. So you can split them up. You can simplify it, and then you can split them up, which I've done in just one step here. So again, I could divide this by 3, divide this by 3 to get 9 and 7, and then join them back into one fraction. Now, instead of multiplying by the square root of 21, which is a larger number, we can rationalize by square rooting, multiplying by the square root of 7. So my outside for the top, 10 and 1 is just 10, and the inside here is going to be 63, which will probably need to be simplified. And the bottom, the outside is a 3, and the inside is 7 times 7, which is 49. So off to the side here, I'm going to do 10 square root 63. Now that can split up to 9 times 7. 9 is 3 times 3, carry down the 7. That's a pair of 3s that we can take out. Take out the 3, there's already a 10 there to make a 30. And then the leftover is just a 7. So this 10 square root 63 simply becomes 30 root 7. And on the bottom of the fraction, we've got a 3 and the square root of 49. And the square root of 49 is just 7. So I've got 30 square root 7 all over 21. And now I need to take a look, is there anything that can be simplified here? Well, the outside numbers, they both can be divided by, looks like 3. So I have 30 divided by 3, which is 10 square root 7, 21 divided by 3, which is 7. So I have 10 root 7 all over 7. I do want to acknowledge this is an incredible amount of work, and it's only going to become more work in the later chapters. So it's really important that you can rationalize something, but also that you can spot that, oh, I can simplify this. So here we have the last one. Again, you could rationalize this by multiplying by the square root of 54. That's going to get absurd, but you could do it. But I do notice that both of these, if I join them together into one square root symbol, so 4 root 3, if I join them together, 45 over 54, they can both be divided by 9. That makes the numbers a lot smaller. So I've got 4, and I've got 3, and I have 45 divided by 9, which is going to be 5, and 54 divided by 9, which is going to be 6. So you can simplify the fractions and then split them back up, which is what I've done here. Now when I rationalize, I'm doing a number that's a lot easier, especially when you don't have a calculator. So on the top, the outside number is a 4, and the inside numbers are 6 times 5, which is 30. On the bottom, the outside numbers are 3, and the inside numbers are 36. So let's take a look for square root 30. Does this need to be simplified? Well, 30 is going to be 6 times 5, or 5 times 6. The 5 can carry down. This is going to become a 2 and a 3. And there are no pairs. So no, I can't simplify it. That's perfect. So I got just 4 square root 30. It already is in simplest form. On the bottom I have a 3, and the square root of 36 is just 6. So I've got a 4 square root 30. And then on the bottom is an 18. 3 times 6 is 18. And these both can be divided by 2. The outside numbers. So the outside number 4 divided by 2 is 2. 18 divided by 2 is 9. And there's a square root of 30. And there you have it. So these are the most complicated in terms of the division questions with just a single term. We are going to get a little more complicated later, but for right now, these are the most that we have.